Assalamualaikum and hello. I'm going to continue with the reaction of carbonyl compounds. Let's focus the chemical reaction that can aldehydes and ketone do when reacts with a few reagents. Let's go to the first reaction, which is addition with hydrogen cyanide, HCN. The reagents that we can use is potassium cyanide with diluted acid H3O+, or you can write it down as another one more form, sodium cyanide with H3O+. So this is the reaction where I have aldehydes or ketone. The reaction will happen the same way, and it reacts with KCN with H2SO4, or you can write this part as H3O+. It is also acceptable. And if you see the name of the reaction here, addition with hydrogen cyanide, HCN, but right now I didn't put HCN at all in my equation. So why? You have to know that HCN is prepared in situ by the reaction of a mixture for KCN and sulfuric acid, or NaCN with sulfuric acid. So what does it mean by in situ? In situ typically means in the reaction mixture. So you have to understand that in a reaction mixture, there are numerous situations in which chemical intermediates are synthesized in situ in various processes. So that's why we cannot say straight away HCN, but we can say that in a mixture of KCN with sulfuric acid, there is a presence of HCN. So get back to the equation. So what will happen to the product form? You will form cyanohydrin when your carbonyl compounds reacts with hydrogen cyanide. And this one will happen when you break this double bond and you will add hydrogen that will attach to O minus, forming OH group here, and you will add up your nucleophile, which is Cn minus. So this Cn comes from this one, K plus and Cn minus. So that's why this Cn attached here, because this nucleophile attack the carbonyl carbon here. So the chemical properties for this reaction is nucleophilic addition. I hope you still remember about the previous video, how carbonyl compounds more prone to undergo nucleophilic addition reaction. Now let's try a few questions from example 4. I have here my aldehyde reacts with potassium cyanide in H2SO4. So what you can see from here, this group CH3 and H is going to stay as it is. But what happened in this, the electron from this pi bond will go towards oxygen because it is more electronegative, and nucleophile from this part, which is Cn minus, will attack here. So the reaction will form cyanohydrin, where my final product, I'm going to copy back the formula. C bonded to 4 bonds, and the first one is attached to methyl group, and hydrogen stay as it is, as you see from this part. And another 2 bonds, one of it is going to attach with OH, and another one more is going to attach to Cn. And this is your product for the first example 4. Now we go to the second example 4. I have here is my ketone, and I use the same reagent. So what will happen? These 2 alkyl groups are going to stay as it is, but the bond will be broken here, and you will form cyanohydrin with carbon attached to OH, and then attached to your benzene ring, and attached to Cn, and last one bonded to CH3. Make sure when you draw your structure for the product, this bond will bond to oxygen, not hydrogen, and this bond will bond to carbon and not nitrogen, because this CN is actually, if you open the structure, it's going to be this carbon has triple bond with nitrogen. So I hope you can still remember all carbon atoms must have 4 covalent bonds. Now let's go to the second reaction, which is reduction with LiAlH4. The full name is lithium aluminium hydride followed by hydrolysis. So when you want to write the name of the reagent, I advise to you to use in chemical formula. You can write it down as LiAlH4, H3O+. And I always use a simple pronunciation for this one is Liah. So I hope you can understand when I talk about Liah, it's referring to LiAlH4. So for your information, lithium aluminium hydride is one of the reducing agents. So I'm going to show you how ketone and aldehyde undergo this reduction process. So the chemical properties in this case is reduction. So the first step is you react your ketone or aldehyde with Liah, and you will form a tetrahedral intermediate where I taught you before in the previous video, where you will form O minus here and H here coming from Liah, and this O minus comes from pi electrons that move towards oxygen, which is more electronegative. And after that, you will undergo hydrolysis where you use H3O+, and that will form the final product, which is alcohol, which your O- will attach to hydrogen to form hydroxyl group. So this is the final product for your ketone or aldehyde. So it depends on which one that you use, whether ketone or aldehyde, they will form secondary alcohol and primary alcohol respectively. If the question asks you to write the chemical equation, you are going to use this form. But if the question asks you to write in synthesis method, you can use the following format, which is you got your carbonyl compounds, reacts with first step 1 Roman Liah and second step H3O+. You have to separate them on the top arrow and on the bottom one, and you will form the final product alcohol. This form only can be used in synthesis question. Now let's try a few examples. I'm going to teach you how to answer this one. I have my ethanol reacts with Liah, so I'm going to form my tetrahedral intermediate with carbon bonded to 4. The first one is hydrogen, CH3 and O-. So these two groups attach to carbon as original. And next one, it will undergo hydrolysis with H3O+, and I'm going to form my final alcohol, which is primary alcohol with carbon bonded to OH and hydrogen, CH3 and another hydrogen. So this is my product, which is primary alcohol when aldehyde reacts with Liah followed by hydrolysis. Now let's go to ketone. I have ketone here, which is 2-propanone. I'm going to make it react with Liah. So the tetrahedral intermediate will be formed where I got my carbon bonded to O- with CH3 on the right, another CH3 on the left, and hydrogen from Liah. And what's next? You got hydrolysis for H3O plus, and my final product I will have carbon bonded to OH with CH3 at both sides, left and right, and one hydrogen for another one more bond left. So this is my secondary alcohol when ketone reacts with reducing agent. Now let's go to the third reaction, which is reduction with NaBH4, and the name for this is sodium borohydride in methanol. So please remember, if you want to write down the name for the reagent, you have to put down in chemical formula the best way, NaBH4, CH3OH, and this is for methanol. Your additional info here, I'm going to call this one as another short name, which is NaBH. So NaBH in methanol is also one of the reducing agents. Same goes for LiAH in H3O+. So I'm going to show how the reaction happen. Actually, it's just the same, but the difference right now, you don't have to show the tetrahedral intermediate. So straight away, when you put your carbonyl compounds as the reactant, reacts with NaBH, with methanol on the top of the arrow, you will form straight away your alcohols. Depends on the class of that alcohol. So these chemical properties is what we call as reduction. Let's try example 6 with me. In order for me to draw the products, you have to understand the reaction will happen around the functional group here. So this carbonyl group. So what will happen, I'm going to draw my structure with carbon, got 4 covalent bonds, and one of it attached to OH to show this product as alcohol, and one of it attached to hydrogen from the original structure, and here I'm going to attach with cyclopentyl. So I have bond with cyclopentyl here, and the last one attached to another hydrogen comes from the reducing agent. So this is my primary alcohol. Next one, we go to ketone, where I have 2-butanone here, reacts with NaBH in methanol. I will form secondary alcohol where my carbon bonded to OH. The next bond is CH2, CH3, and CH3, and last one with hydrogen. So this is my secondary alcohol. So I hope all of you understand how to write the chemical equation for the reaction of carbonyl compounds, whether it is aldehyde or ketone. That's all for this video. I'll see you in the next one. Thanks for watching. Please like, subscribe, and share.